Okay, I would encourage you to take the region first on your own before watching this. If not that, at least try to do each problem first before watching the solution. And then also, again, after watching the solution, try doing it again on your own to make sure that you can do it on your own. And then also I would do it a couple hours or days later to make sure that you really got it. Okay, let's start off with number 1. So I'm assuming that you already read and tried the question, so I'm not going to bother reading each question. Now, if we look at what they're asking for 6 members, so that would be right here. So if we look at the line, it would be approximately something like this, which would come out 6 family members. That would be right around there. Right? Even if you look, another way of looking at it is like this. It's going to be smack in between these two, right? Minimum, maximum, smack in between, comes out to around 300. Also, you'll notice that 2 family members is about 100, so that comes out to about 50 per member. So if you scale that up to 6 members, that's going to be 6 times 50, which is also 300. So that works out nicely. Okay, oops, skipped a little bit there. Number 2. So a function. The way a function works is a function is like a machine. For example, where you put something in, you get something out. For example, f of x equals x plus 1. So this is a machine that whatever you put in, right, this is the input, right, whatever you put in, it adds 1. So if I would, let's say, put in a 1, f of 1, that would be 1 plus 1 equals 2, right? I can have another machine function / machine that it takes whatever you put in, it squares it, and then adds 3. So if, let's say, I put in a 2 into this machine, right, it's going to take the 2, square it, and add 3. Right, 2 squared is 4, plus 3 is 7. So that's how this machine works, this function works. Okay, so in our case, the function g of x, what it does is it takes the number, squares it, multiplies by -2, and adds 3 of them. So really all we need to, and they're asking us for g of -3, meaning that the input is -3. So really all we need to do is plug in -3 for x. So g of -3 is going to be -2 times, right, we're plugging in -3 for x, -3 squared plus 3 times, again plugging in -3 for x, right, exactly like it is here, just replacing the x with a -3, right, and we can do that on the calculator. -2 times -3 squared plus 3 and we get -27. Okay, so the answer is 1. Okay, this is a very useful skill, plugging in. So another way you could do it, and this is useful if you want to plug in, try plugging in multiple numbers, is you can graph it. So if I'm graphing g of x here, right, that's -2 x squared, plugging it in exactly as they have it over here, plus 3x. Alright, so I can graph it, or I can look at the table. Now this table shows me when I plug in 0, meaning g of 0, if x was 0, I would get out a 0. When x is 1, if I plug in a 1, I'll get out a 1. When x is 2, I get a -2. When x is 3, I get a -9. Uh-oh. Did I make a mistake somewhere? -2x squared plus 3x Oh, because I'm looking for -3. Okay, right. So when x is -3, I'm going to get -27 right there. Okay. Next problem. Which expression results in a rational number? So a rational number is a number that can be expressed as a decimal or a fraction. The way you can tell if it's a rational number is if it has a very long continuous decimal. So this is really simple. All we have to do is just plug in each choice here. So let's try the first one. Choice 1, square root of 121 minus so that's an irrational number. See all those numbers after the decimal point? That tells me it's an irrational number. Square root also irrational. Right? And both of these are irrational because an irrational number, if you multiply an irrational number times a rational number, you'll get an irrational number. Also, if you subtract an irrational number, you'll get an irrational number. Choice 3, I'm pretty sure both of those numbers are rational, so we should get a rational result. Let's just make sure. 36. And there, we got a rational result. This is important on the region. You should check each choice. Even if you check a choice and it looks right, you should check all of them. If you're getting 2 right answers, then that's a hint that you made a mistake somewhere, and you should go double check your work. So I'm not going to do that here just to save time, but on the region, you should check every single choice. Okay, moving on to number 4. Okay. So each textbook costs $116, and the laptops cost $439. So the total cost is going to be 116 times the number of textbooks, put in a T, plus 439 times the number of laptops, right? And they have only 6,500, so this total amount that they're going to spend has to be less than 6,500. Now, they told us that they purchased 30 textbooks, so that means we know T, the number of textbooks, is 30. So it's 116 times 30 plus 439L. $3,480. Subtract this from each side. Oops, what happened there? $30.20. So L has to be less than 6.76 since we have to, it has to be a whole number, right? You can't buy a half a laptop. So therefore L is going to have to be 6. Okay, even without doing any of this math, you could also figure it out logically by realizing that, okay, they have $6,500 to spend, and they spent, how much of it did they spend on laptops? They spent 439, how much of it did they spend on textbooks? 116 times 30. So 116 times 30. So that's how much they've already spent, and they have 6,500. So this is how much they have left. Okay, so far simple, right? They started off with 6,500. They spent 3,480 on textbooks because they told us that they bought 30 textbooks. So they have 30.20 left. So now just try each choice. If let's say they bought 6, could they buy 6? Well, let's see. 6 would cost 6 times 439. That comes out to 2,634. Okay, they could buy that many. What about 7? Could they have bought 7? 7 times 439. That would be 30.73. That would be too much. They only had 30.20 left, right? After buying the textbooks, they only had 30.20 left. So they could buy 6, but 7 is going to be too much. Okay, next. So this we could solve algebraically by multiplying each side by 5/3 and then subtracting 4/3 from each side. But we could also do this using the calculator. So this is a very useful trick. Anytime you have an equation, they're asking you for the solution of the equation, y1 equals left side, y2 equals right side, and then find the point of intersection. So I'm going to put y1 equals left side. y2 equals right side. And graph. Okay, and I could see that I'm going to have a point of intersection right over there. Now to find that exact location, I do calc, intersect. Now enter 3 times, 1, 2, 3, and they give me my point of intersection is when x equals 0.4. 0.4, so that's choice 2. Okay, now if if you don't see a point of intersection, you might have to use zoom fit or zoom out, or change the windows and then do zoom fit. If for whatever reason it's just not working, you're not finding a point of intersection, here's another method you can use. Math, alpha, apps, equation. So this is the equation solver. Expression 1, I'll put in expression 1. Expression 1 is going to be the left side. 3. You could also use this as a way of checking, double checking to make sure that you got the right answer using 2 methods. It's more reliable than 1. There are downsides to this method, that you can't visualize it and see if there are multiple solutions. Sometimes there are multiple solutions, and you won't see that if you're not graphing it. 4/3. And expression 2, that's going to be the right side of the equation, 1.04. Enter for OK. Now this is kind of like the guess. X equals 0.4, it's the guess. It's going to give you the closest solution or point of intersection to whatever that guess is. The bound is like the range of what it's in between, right? So this is kind of like, it's just saying in between a really small number and a really big number. Okay, so now I press alpha, solve, and it gives me my solution is 0.4. Okay, so those are our two methods. Personally, I prefer the graphing and finding the point of intersection, but if for whatever reason it's not working, you can use this method. Okay, number 6. So what you can do in this problem is you can FOIL each one of these out and see which one comes out to this. Or you can graph. Basically, you want to find which of these choices is equivalent to the expression in the question. So you can just graph the expression in the question, which is 3x squared minus 10x minus 8. And then, let's say, choice 1, 3x plus 2 times x minus 4. Now you can do it by graphing. Personally, I prefer to use the table. Now, if they're equivalent, then they should be coming out exactly the same as they are, right? As you can see, when x is -3, they're both coming out to 49. When x is 5, they're both coming out to 17. So it looks like they're both the same. On the region, you should go through each choice just to make sure, just to double check. If you're getting two correct answers, then you should double check your work. Just to save time over here, I'm not going to do that. Just one point, though, I do want to point out to save some time is you don't have to delete this each time or type out all of them. You can just edit it. Let's say now I want to test out choice 2. Instead of erasing and retyping the whole thing or having a whole bunch of lines there, I can just change this minus to a plus. There, now I have choice 2 checked, right? And then I can just go to the table. And as you can see, they're different, right? Y1 is different from Y2. So that tells me they're not equivalent. So, and you could do that for all the choices, just edit instead of rewriting. Okay. Which expression does not represent a function? So with a function, for each x value, you're only going to have one y value. So over here, right, each x value only has one y value. I don't see any repetition. If this was, let's say, a different number, if this was, let's say, a 2 or a 5 or a 6 or one of these numbers, right, if I had a repetition in the x column, or row rather, then that would not be a function. But I don't have any repetition, so it's 1-to-1, so it is a function. This, you can see, is a function. You can graph it, type it into your y equals and graph it. You'll see that I believe it will look something like this. So it passes what's called the vertical line test, right? Each x value will only have one y value, right? If it came out looking something like this, that would not be a function because, let's say, this x value has two y values, right? It would fail what's known as the vertical line test. The vertical line test is if you can draw a straight line that hits the function, that hits the curve twice, right? One straight line for an x value that hits the curve twice, then it fails the vertical line test and it's not a function. This, right, it passes the vertical line test. You cannot draw a straight vertical line that hits it more than one place. So for each x value, there's only one y value. Over here, for each x value, there's more than one y value. For example, 1, right? An input of 1 puts out 4 and 5, right? So when I say if I put in 1, what do I get out? 4 and 5, that can't be. There's only one output for each input. So the answer is 4. 4 is not a function. Okay, so what she did in this step was she distributed 3 times 2x and 3 times 3, right? So she used the distributive property to multiply over addition. So it's 4. What else did she use? She used the commutative property. So you notice the order changed here. Over here it's -8 minus 10x. Over here it's minus 10x minus 8. That's the commutative property. The commutative property tells us that the order doesn't matter, right? 5 plus 3 is the same as 3 plus 5. So use the commutative property and the distributive property. So that would be choice 4. Okay, number 9. The zeros of the equation. So the zeros are when the function equals 0, meaning when y is 0. So that's going to be over here and over here. Right? Also over here and over here. Right? These are when y is 0, right? When x is -2, y is 0. When x is 4, y is 0. So this would be A, and this would be B. Sorry, this would be C, actually. B, over here, that's not a 0. That's where x is 0, not y is 0. So that is not a 0. The zeros are where y is 0, where the function is 0. So A and C can determine the zeros of the equation. So the answer is 3. Okay. So the rule with transformations is as follows. If I have f of x plus 1 plus a outside, that shifts a units up. If of f of x minus a, that shifts a units down. F of x plus a inside, so that shifts a units left. And f of x minus a inside shifts it a units to the right. So what I have here is in this one is on the inside. So that means it's going to be shifting to the right 1. And the -2 is on the outside. That means it's going to be shifting down 2. So right 1, down 2, which is choice 3. Why isn't this working? There we go. Okay. Number 11. Okay, so C minus 2D. They told us C equals 2a squared minus 5. So that's 2a squared minus 5 minus 2D. D, they told us, is 3 minus a. So I'll show you a trick for solving this in a minute, but the proper way to solve it is 2a squared minus 5. Then you distribute this -2 through here. So -2 times 3 is -6 minus 2 times negative a is, right, negative times negative is positive, plus 2a. So now we combine like terms, we have 2a squared, okay, so there's no other a squared terms. 2a squared. Then we have plus 2a, there's no other a, plain a terms, so plus 2a. But then we have two like terms over here, minus 5 and minus 6, that comes out to minus 11. So we get 2a squared plus 2a minus 11. Now, a little trick for doing this would be to give a value. So let's say we assign a value of 2. Okay, so if a equals 2, so then we'll have 2 times 2 squared minus 5, and d will equal 3 minus 2. So if a equals 2, then c will equal 2 times 2 squared, that's 8. I'll just put it in the calculator anyways. Minus 5 is going to come out to 3. So if a is 2, c will be 3, and d will be 1. Okay, now if c is 3 and d is 1, then c minus 2d would be, right, c, why isn't this working? C minus 2d would be 3 minus 2 times 1, which would come out to 3 minus 2, which equals 1. Now, all I have to do is plug in a 1 for a in each of these choices and see which one comes out to 1. So if a is 1, over here I would get 2 times 1 squared, which is 2, plus another 1, which is 3. Sorry, we said a is 2. So 2 times 2 squared, that would be 8. Plus another 2 would be 10, minus 8 would be 2. So that wouldn't work. We need it to be coming out to 1. 2 times 2 squared, that would be 8, minus 2 minus 8, that would come out to negative 2. That wouldn't work. If I plug in a 2 for a here, I would get 2 squared is 4 times 2, that's 8, plus another 2 times 2, that's 4, so 8 plus 4 minus 11, 8 plus 4 is 12, minus 11, that comes out to 1, so that would work. So 3, it could be 3, we know it can't be 1 or 2. What about choice 4? Plug in a 2, we get 8 minus 2 minus 11, that's coming out to a negative number, that's not coming out to 1. So using both methods, we came to the same conclusion, which is good, that it's choice 3. Okay, number 11. So one way we could do this is graph each one of these and see which one matches this table here. So let's see. To the power of x, check the table. Let's see, according to the table, according to the calculator table for choice 1, when x is 1, y1 is 12,000. That already doesn't work. We can eliminate choice 1. Now we don't have to erase the whole thing. We can just edit it to check choice 2. Choice 2 will be 0.8. Now let's check the table, see if it matches. According to our table, when x is 1, y is 800. That doesn't work either. Let's check choice 3. This time we have to change this value also. So it's 1250. 1250 times 1.2. Check the table. I have to wait for it to finish graphing. Why isn't it giving me the table? There we go. Okay, when x is 0, y is, well, when x is 1, y is 1500. That doesn't work either. Don't assume that it's choice 4 though. Check it, because it could be that we made a mistake and really it's one of the previous ones. So don't use process of elimination if you don't need to. And 1 comes out to 1000, 2 comes out to 800, 3 comes out to 640, so that all matches, so it's choice 4. Okay, number 13. So, the answer over here is choice 1, the initial height of the ball. Why? Because x is representing the amount of time, right? The initial time, right, meaning when it starts, that's going to be when x is 0, right, after 0 seconds. Right, when x is 0, we have, this is going to be 0, because anything times 0 is 0. This is also going to be 0. We're going to be left with 5, right? So the constant number, right, at the end, that's our initial height, right, because everything else is 0. The time that the ball reaches the ground, when is that? That's going to be when the function is 0, when this whole thing is 0, right? To find that, we would graph y1 equals this whole thing, y2 equals 0, and find the point of intersection, right? That would tell us, and the x value would tell us, sorry about that, and the x value would tell us when the ball hits the ground. Choice 3, the time at which the ball was at its highest point. To find that, we would graph it and then use the maximum function on the calculator. Maybe we'll get to that later. And the x value would be the time that the ball was the highest, and the y value would be the maximum height that the ball attained when thrown in there. So it's 1, right? The constant at the end, without an x next to it, that's the initial height of the ball. Okay, domain and range. Domain is the possible x values, range is the possible y values. So if the domain is the integers, meaning the whole numbers, from -2 to 1, so what's the range going to be? So to find that, I can just graph this and see what the y value will be for every x value from -2 to 1. So let's graph that. Y equals 2x squared okay, now go to the table. Okay, so -2 to 1. So let's see, when it's -2, I get 16. When it's -1, I also get 16. Sorry, -16. So -2, -1, that's 16, 16. 0 is -12, and 1 is -4. So if my domain, they told me, is -2 to 1, my range is going to be -16, -12, and -4. And that's it. -16, -12, and -4. -16, -12, and -4. So that's this. Okay, which equation has the same solution as x squared plus 8x minus 33 equals 0? So all I have to do is, the way that they're expecting you to do it is by completing the square. If you don't know how to do it, you can get around that by finding the solution for the equation in the question and find the solution for the equations in the choices and see which one matches. So let's start off with the expression in the question. X squared, so y1 equals left side, y2 equals right side, and find the point of intersection. So to find the solution, we're going to do x squared plus 8x minus 33, y1 equals left side, y2 equals right side, 0. And now we're going to want to find the point of intersection. Okay, so I see one point of intersection here. There's probably another one further down to the right. But this should be enough. So I already did calc intersect, so I'm just going to enter, enter, enter. And I'm getting a solution is 3. Actually, you know, let's zoom out a little bit, because I have a feeling it's going to go down to the right, and there's going to be another point of intersection. But let's just write down what we have so far. Oh, actually, it's to the left. There's the other point of intersection is to the left. Okay, so let's just write down what we have so far. 3, and now let's find the other one. Calc intersect. Now we have to make sure to move closer to the other one, right? We want the one on the left now. We already have this one, and that's at 3. Oops. We want the one to the left now, so let's move to the left. Enter 3 times, and we get -11. So those are the two solutions for the equation in the question. Now we just have to find which of these choices have that same solution. So let's start off with choice 1. X plus 4 squared, y1 equals left side, x. Make sure to type it in exactly as it's written with the parentheses, x plus 4 squared. And y2 equals right side, that's 49. We might have to zoom out because it's 49, that's going to be high up. Let's see if it's high up enough. No. So you could zoom out, or I prefer zoom fit. Either one will work here. There's also that other method that I showed you before, Math Alpha Apps. You could use that too. Okay, calc 5 intersect. Let's start with the right point of intersection. Enter. And 3. So it has 1 point. Let's see if it has the other point. Calc intersect. Let's move to the other point. 1, 2, 3. -11. Oh, we were lucky. The first choice, right? If it and on the region, you should of course check every single choice so that you'll catch any mistakes. If you get more than one correct answer, then you should double check your work. Okay, and also again, you don't have to erase this and retype the whole thing. You can just edit it to make sure it matches, right? You could just change this from x plus 4 to check choice 2, change it from +4 to -4. Okay, this is a little bit of a hard one, not too hard actually. Okay, so they told us that Liam's pumpkins grow at a constant rate. That means that it's going up the same amount each time. Now, to see how much it's going up each time, just if you want to see the choices, really should have a separate test paper, but okay, so it's going up the same amount each time. To see how much it's going up each time, just subtract one from the other. So let's say at week 6 it was 2.4, week 7 it was 5.5. So to find how much it's changing each week, we just do 5.5 minus 2.4. And we get 3.1. So that means it's going up 3.1 pounds each week. And just to double check, let's try 11.7 minus 8.6. It should come out the same. 8.6. 3.1. So we know it's going up 3.1 each week. So now week 10, it's going to be 3.1 plus 11.7. 11.7 plus 3.1. That gives us 14.8. So let's 14.8. And the week after that, 17.9. And the week after that, 21. And last one, the week after that, well, really, I could do this without the calculator, but whatever. 24.1. Okay, Patricia's is a drop more complicated. It's not going up a set amount, it's going up a percentage. So let's see. So for it to be going up a certain percentage each time, so that would be, you would multiply, right? Let's say it's going up 52% each time. You would multiply by 1.52. So let's say 2.5 times 1.52, that should come out to 3.8, unless they lied. Sorry. Right, the 2.5 I'm getting from here, right, times 1.52, that should be an increase of 52%, right? 1 to keep the original and 52.52 for the increase. So let's see, 2.5 times 1.52, 3.8, just like they got there. So that's something important to know. An increase of X percent, right? To increase something by X percent, you have to multiply by 1 plus that percent. So if let's say you have $7 and you want to increase by 3%, that's going to be 7 times 1 plus 3% is the same as 0.03, right? Times 1.03. So that's how increasing percents work. So if it's increasing by 52% each week, so at week 9 it's 8.8. So to find week 10, it's going to be 8.8 times 1.52. 8.8 times 1.52. That's going to give us 13.376. And the next week, we'll do the same thing, times 1.52. That's 20.3. Here we go, 20.3. 30.9, so we're already way past Liam's pumpkin growth. Let's just finish. 0.52, 46. Okay, so Liam's pumpkin will weigh more in week 10 and 13. Well, in week 10, yes, but in week 13, Patricia's is way ahead, so that's out. Patricia's will weigh more in both, no, because in week 10, Liam is still higher. Liam will weigh more in 10, and Patricia will weigh more in 13. That is correct. Okay. Next. So the domain, right? As we said before, the domain is all possible x values. So I can see the x starts at -1, right? And it goes, this arrow tells me that it keeps going, right? So it starts at -1, and it keeps going on forever. So it's not all positive real numbers, because it includes from 0 to -1, which are negative, right? It includes this whole range here, which is negative. So it can't be choice 1. All positive integers, no, because, first of all, it includes all integers are only whole numbers, but this includes even irrational numbers like pi. And also, it includes negative numbers. So choice 2 is out for 2 reasons. X is greater than or equal to 0. No, x could also be between 0 and -1, right? This range here, right? So all choices 1 through 3, we're saying that x has to be positive, but that's not true. The domain of x includes -1, right? And just to remind you, this closed circle means it includes -1. If it was an open circle, it would mean just up to -1. But even if it was an open circle just up to -1, it would still include, let's say, -0.5, -0.9, all the negative numbers until -1. But since this is filled, right, so it has to be, so it includes -1. So x including -1, right, x can equal -1 or it can be greater. X is greater than or equal to -1, that's choice 4. Okay, which pair of solutions would have -1, 2 as a solution? So you can do this by finding the solution for each one, right? To find the solution for, let's say, choice 1, you would graph y equals x plus 3 and y equals 2 to the power of x. And you would find the point or points of intersection. I'm going to have to fix the graph here a little bit. So let's try to zoom standard. So I see 2 points of intersection. Are either of them going to be -1, 2? Well, let's see. Calc intersect. So let's make our guess near -1, near when x is -1, because that's really the area that we're interested in. Enter. So no. That point of intersection is not at -1, 2. This is -2.8. So this is too far. -1 would be like over here. There's no point of intersection there. So choice 1 is not a solution. Another way we could have done it is by just plugging in -1, 2. this negative 1 comma 2 means that when x is negative 1, y will be 2. So we can plug that into here. When x is negative 1 over here, will y be 2? Well, negative 1 plus 3, yeah, y will be 2. So that works. But what about here? 2 to the power of negative 1. 2 to the power of negative 1, you can type into your calculator. Right, this is using the plugging in method, right? Plugging in this point, negative 1 comma 2, and seeing if it fits. This y equals 2 to the power of x. So 2 to the power of negative 1 should come out to a half. Right? Comes out to a half. So that does not fit the solution, right? If it fit the solution, then y would be 2. But y actually, when x is negative 1 here, y comes out to a half. So it does not fit this. Okay, now let's try choice 2. So choice 2, we can do the same way. We can either graph each of these, right? X minus 1. Oops. X minus 1 and 2x. And then find the points of intersection. Right? Or we could plug in the points, x is negative 1, y is 2, and see if the equation comes out true. If x is negative 1 here, negative 1 minus 1, that would be negative 2, not 2. So the point negative 1 comma 2 doesn't fit here, because when x is negative 1, y does not come out to 2. And over here also, when x is negative 1, y does not come out to 2. It comes out to negative 2. So I can already tell that choice 2 is not going to be correct. Let's just see the point of intersection. Yeah, here is at negative 1 comma 2. Sorry, and negative 1 comma negative 2. So that will not, it looks like about there. Whatever it is, it's certainly not negative 1, 2, which would be over here, right? So we can eliminate that. Choice 3, same thing, right? y1 equals x squared minus 3x minus 2. Oops. And y equals 4x plus 6. Graph. And while we're waiting for it to graph, let's plug in negative 1 squared minus 3 times negative 1 minus 2. So negative 1 squared is 1 minus 3 times negative 1. That's going to be minus 3. So 1 minus 3 is negative 2. Negative 2 minus 2, that comes out to 0. That's not going to work. So unless I am making a mistake with my mental math. Oh wait, maybe I am making a mistake. Let's see. So this looks like it might work actually. 5 intersect negative 1 comma 2. So negative 1 comma 2 is a solution here. Where did I go wrong with the mental math? Negative 1 squared is 1 minus negative 3, which is minus a negative is plus, so plus 3, which is 4, 4 minus 2, it comes out to 2. Yeah, so this works. Plugging in negative 1 here, we would get negative 1 times 4 is negative 4, plus 6 equals 2. So yeah, this does work. And of course, as always on the Regent, you should check each choice. No, but we're not going to do that for now. Okay, so the sequence is 8, 2n, 50, blah, blah, blah. Okay, so what this means is a sub 1 means first term. A sub n means the nth term, meaning, let's say a sub 2 would be the second term. Now, a sub n minus 1 essentially means the previous term. Why? Let's say I'm talking about the third term, right? So if I'm talking about the third term, right, when n equals 3, a sub n minus 1 is going to be a sub 3 minus 1, right? Because I'm talking about the third term, so n is 3. 3 minus 1 is a 2. So when I'm talking about 3, right? The third term, when n is 3, a sub n minus 1 is going to be a sub 2, which is the previous term, and that's going to be for any term n, right? Any term n, a sub n minus 1 is always going to be the previous term. So let's say what choices 1 is. So for all of them, a sub 1 is 8, right? It starts off at 8. Our first term is 8. What choice 1 is saying is each term is going to be, right, a sub n, each term is going to be a sub n minus 1, the previous term, plus a1, which is 8. So let's try out choice 1. Choice 1 is saying, let's check what the second term would be according to choice 1. A sub 2 would be a sub n minus 1, n is 1 here, right? So 2 minus 1, plus a sub 1, which is 8, right? So here, right? When n is 2, meaning the second term, it would look like this. So a sub 2 would be a sub 2 minus 1 is 1, right? So this would be a sub 1 plus a sub 1. And as we know from here, right, a sub 1 is 8. So the second term would be 8 plus 8, which is 16. So according to choice 1, the second term would be 16. But we can see over here, the second term is 20. So this is out. Choice 1 is out. Now, if you can, try to pause the video and try checking the rest of the choices yourself. Now I'm going to do it. Let's see, the second term is going to be, right, when n is 2, so a sub 2, that's the second term, is going to be 2.5. So what this is saying is each term is going to be 2.5 times the previous one. So checking the second term, a sub 2 is going to be 2.5 times a sub 1, and we know a sub 1 is always 8 in this problem, right? That's what they told us at the beginning. So a sub 2 is going to be 2.5 times 8, which is actually going to be 20, right? If you're not sure, you can check your calculator. Even if you think you're sure, it can't hurt to double check. 2.5 times 8 is 20. So that works. So, and really you should keep checking. The next is going to be a sub 3 is going to be 2.5 times the previous term, which is a2, which is 20, times 20. 2.5 times 20 comes out to 50. So that works, right? And yeah, that should be good enough. Well, you should really try each choice, try choices 3 and 4 to make sure those don't work. If those work, then you made a mistake somewhere and you have to double check your work. Okay, number 20. Okay, so this is a little bit confusing for some students. It really just requires a bit of basic algebra. They're asking us to get I alone, right? They're asking us to get I in terms of P and R. So the first thing you would do is divide each side by R. I'll show you a trick way around this afterwards. Divide each side by R, so you get P over R equals I squared. And then you just take the square root of each side. So you get the square root of P over R, right? Because the square root of anything squared is itself, equals the square root of I squared, right? The square root of anything, the square root of anything squared is itself, so we get I equals the square root of P over R. And that would be choice 2. Now, here's a trick that you can use if that's too difficult. You can give I and R a value and see what P will equal, and then see which of the choices matches matches that. Let me show you what I mean. Let's say for example, I equals 2 and R equals 3. Now, if I equals 2 and r equals 3, what will p equal? What will p equal using this equation, right? So they told us p equals I squared times r. So if I equals 2, that's 2 squared times r, which is 3. 2 squared is 4. 4 times 3 is 12. So now we know if I equals 2 and r equals 3, p will equal 12. Now let's see which one of these matches that. Let's say in choice 1, right? Is it true that I is 2, is it true that 2 equals p is 12 over r, which is 3 squared? Is it true that 2 equals 12 over 3 squared? Well, you could type into your calculator, but 12 over 3 is 4. 4 squared is 16. 2 does not equal 16. So that doesn't work. Now let's try plugging in our numbers, right? I equals 2, r equals 3, and p equals 12. Let's try plugging that in here. I, which equals 2, equals the square root of p, which was 12, over r, which is 3. Well, you could type into your calculator the square root of 12 over 3, but 12 over 3 is 4, right? The square root of 4 is 2, so yes, this does work. Now, if you're using this method, it's extremely important to check each choice, because it could be that more than one choice will work. If more than one choice will work, then, well, you'll have eliminated the other choices, but you'll have to pick another value for I and R, right? Let's say make I 1 and R 2 and find the value of P, and repeat the process for the two solutions that worked. For example, if let's say choice 4 also came out true, that I was 2, R is 3, and P is 12, and that worked here, you would give I and R another set of values and repeat this process just with different values for I and R. Okay, 21. Okay, when the input is 4, which functions have the same output value? Okay, so when the input is 4, the input is the x value, right? So 1, 2, 3, 4. So the input is 4. In this, in f of x, the output value is 1, 2, 3. So for number 21, when the input is 4, the output is 3. We'll come back to this one in a minute, because this one's easier. Over here, right, when the x input is 4, the output of p of x is 3. So those two are the same. Now for this one, you could either just plug in 4 yourself, or you could type into the calculator, or you could graph it and use the table. Right, just like we did in, I forgot which one it was, I think it was number 2 or 3, question 2 or 3. Just plug in the value of 4 for x and see what you get out. So you'll get out 3. So all of them, when you put in 4, you get out a 3. So that's choice 4. Okay, this one's going to be kind of hard to do without a calculator. But it's not that hard. Substitution means that if let's say I say A plus B equals C, right? And then I tell you B plus C equals D. So I can replace C with A plus B. Okay, that's not a great example. But that's the general idea, right? If I know C equals A plus B, I can replace C, I can substitute it with A plus B. Okay, so now applying that here, if I know that A plus B, if I know that Y plus 3X equals negative 4, so then, So then I can express y in terms of x by substituting 3x from each side. I get y equals negative 4 minus 3x. Now I can substitute this y with negative 4 minus 3x. So I can rewrite 2x minus 3y equals negative 21. I can rewrite that substituting this y with negative 4 minus 3x. 2x minus 3 times, replacing this y with negative 4 minus 3x equals negative 21. And that should be one of these choices. 2x minus 3 times negative, oh, they decided to play it a little bit tricky. This, negative 4 minus 3x, is the same as negative 3x minus 4. So, we decided to be a little bit tricky and switch around the order there. Okay.